Good morning. This is your stat sensei, Mr. Spensei, and this is going to be a warm up for an introduction to errors. And I'm going to combine the warm up and the exit together. So, in the warm up, the first question is a credit card company with more than 35,000 cardholders with current mean balance of 2,500 tried to increase card usage by offering frequent flyer miles. All right, so we have this amount initially. The company gave free miles to a simple random sample of 36. So there's our sample size N is 36. And customers have found the sample mean, our X bar, to be 2542. So there's our X bar with a sample standard deviation of 109. So because it's using the sample standard deviation, this lets me know we're using a t-test. And then once it's a test at alpha equal 3% to see if card usage has increased. All right, so our hypothesis, HO, well, the status quo is 2,500. I'm going to put a dollar sign so I have a label for it. And the HA, we're going to have 2,500. But we want to see that it has increased. All right, so it wants us to plug. Well, I'm going to go ahead and write the formula right here, even though it's not required. The formula is just going to be T equals X bar minus mu S divided by square root of N. So when I plug into that, I'm going to have T equals, well, my sample mean was 2542. The claim mean was 2,500. The standard deviation from the sample was 109. And we had a sample size of 36. So let's go ahead and run that real quickly. Stat test. This will be a t-test. We have statistics, so we're going to put that in there. Our mean was 2,500. That's the claim mean. That's what the status quo has been. Our sample mean was 2,542. Our standard deviation was 109. We have a sample size of 36. All right. And we need to make sure that we have a greater than symbol highlighted. We do that, and we get a t statistic of 2.311. So the probability that t is greater than 2.3119 equals a p-value of 0.0133. So here's our p-value. Our alpha is 0.03, make them the same length. 133 is less than 300. So with the p-value being small, we're going to reject the null. All right. So the question is, what type of error did we commit? Well, actually, we have no idea if we committed an error. We just know that we might have committed an error. Well, if you reject, the only type of error that you could have committed is a type 1. We never know that we committed one. We have to do a lot more work to know it. And if we knew it, we'd go back and fix it because the errors only happen by random chance alone. Not because we did anything wrong, just by random chance we got a bad sample. So type 1 error was committed. We don't know that it was committed. A type 2 error could not, by the way, it could not have been a type 2 error. If you reject, the only type of error that you might have committed is a type 1. All right. So 1C, you may have committed a type 1 error, but we don't know that you did. The only type you could have committed is a type 1. If you fail to reject, you could have committed a type 2, might have, but not guaranteed to. Well, we rejected, so the only type that we might have committed is a type 1. All right. Scenario 2, losing it. And that should be, wow, that's horrible. Need to fix that. Losing it. A nutritionist claims that the average loss for a new diet plan is 8 pounds. A random sample of 35 individuals from a group of 2,500 dieters who followed the diet plan showed an average weight loss of 8.7. So here's our sample size of 35. Here's our X bar, and we know it says average. That came from the sample. This is what they're claiming. So this is probably my mean. And they have a sample standard deviation of 1.9. Because we're using the sample standard deviation, this lets me know that we're working with a t-test. Conduct a hypothesis test with an alpha equal 1.1% to determine the mean weight loss is greater than 8 pounds. All right, so HO, mu equals 8 pounds. HA, the mean is greater than 8 pounds. I'm going to go ahead and write the formula. T equals X bar minus mu, because the next thing I have to do is plug in. So when I plug in, I'm going to have T equals, well, X bar was 8.7. I had an 8.7 pound sample. The population claim is 8. The standard deviation of that sample was 1.9, and the sample size was 35, which is large enough to be normal, approximately normal by central limit theorem. So let's go ahead and run our t-test, stat test, t-test, and the mean was 8. The X bar was 8.7. The sample mean was 1.9. And N is 35, and they wanted a greater than. And I end up getting a p-value of 0.018. So let's write this down. The probability that T, well, my alternative is greater, so this needs to be greater than our T statistic of 2.179 equals 0.0181. 0.0181. And we have an alpha of, we're testing at 1%, 0.0100, because we want them the same length, the same number of decimal places. Well, I can look at this, and 181 is definitely bigger than 100. With that being the case, I'm going to fail to reject. All right. Fail to. Oh, actually, I probably should have written the word TO, but I just know if I put fail to reject, then I might have committed a type 2 error. So that gets rid of type 1. We could not have committed a type 1 error if we failed to reject. All right. When we do this, we don't know that we committed an error. We just know that we might have committed the error. So we don't know that it was committed. So that's possible, but the better answer is to say that it may have been committed. We don't know if it happened. We didn't make a mistake. We just may have gotten a bad sample by random chance alone. All right. So the next one, scenario 3, got to stop. A pit crew claims that its mean stop time for 4 tires and fuel during the Daytona 500 is less than 13 seconds. So the claim is 13 seconds. A random sample of 32, so we have a sample size of 32. Pit stop times has a sample mean and standard deviation of 12.9 and 0.21 seconds, respectively. All right, because this comes the sample standard deviation, this lets me know I'm working with a t-test. There are approximately 380 pit stops at the Daytona 500. Tested an alpha equal 0.05 to determine whether pit stop time is less than 13 seconds. All right, so here we go. The hypothesis. The hypothesis is, well, the status quo is 13. mu equals 13 seconds. HA, mu is less than 13 seconds. I'm going to write my formula. T equals x bar minus mean S divided by the square root of n. So sample mean minus population mean sample standard deviation divided by the square root of n. And because we're using the sample standard deviation, we have to use a t statistic. So plugging in, t equals 12.9 minus 13 divided by 0.21 divided by the square root of 32. So when we go ahead and run this thing, it's going to be a t-test, stat test, t-test. 13 is the population mean or claim mean. Our sample mean is 12.9. The standard deviation is 0.21. And n is 32. And we have a less than highlighted here, or we have a less than on our alternative. So that's what I need highlighted. I press calculate, and I get probability that t is less than negative 2.6937 equals 0.0056. So 0.0056 and 0.0500. Well, 56 is definitely less than 500. So we're going to reject the null. I want to take a moment and talk about these real quickly. Every single one of these tests were run properly. They took random samples. N was less than 10% of the population, and our the sample sizes were large enough to be normal by central limit theorem, or approximately normal. So all the conditions were met. Everything was done correctly. So you can run the test correctly and still have an error. And the reason that can happen is because random chance. If you put your hand in a bag and draw 30 names, your 30 names that you draw are probably different than the 30 names that I draw if there were like 1,000 names in the hat. Okay, so no errors could have been committed because the test was run properly. Not an answer choice. An error could always happen by random chance alone. So this could always happen. We could always have an error just by random chance alone. Okay, the other thing is if you reject, you cannot commit a type 2 error. So that gets rid of our type 2 answers. It could only be a type 1. But we don't know that we committed an error. We just know that it could have happened. All right. We never know that we made an error. We'd have to have a lot more information at the very end or afterwards after we ran everything to know an error was committed. All right. I appreciate you watching. Look forward to seeing you on the next one. Hope that helped with errors. Bye.